Here we have a SAT math problem. Okay, let's go to the question. Quadrilateral ABCD has sides AB equals to AD and BC equals to CD, where AB equals to 7 and CD equals to 20. The two diagonals AC and BD intersect at point G, and both GB and GD has a length of 2. The length of AC can be expressed as the square root of P or positive square root of W. Find the value of P positive W. Okay, to get the value of P positive W, we need to get the length of AC in this form, square root of P positive square root of W. Okay, first let me draw a quadrilateral. Here I have drawn a quadrilateral. Let me mark the vertices. Let me take vertex A over here, B over here, C, D, and also let me draw the two diagonals. That is, one of the diagonals is AC, and other diagonal is BD over here. And the question says AB and AD are equal. That is, this side AB and AD are congruent, and also BC and CD are congruent. Okay, BC is over here and CD is over here. We have the length of AB is 7. Okay, then the length of AD is also 7 because both of them are equal. And we have the length of CD, that is 20. Then the length of BC is also 20 because BC and CD are equal. Now let's consider the information we have over here. That is the two diagonals AC and BD intersect at point G. Here we have the point of intersection of the two diagonals, so that is G. And we have the information both GB and GD as a length of 2. So the length of GB is 2, the length of GD is also 2. Now let's consider the two sides of the quadrilateral AB and AD. These two sides are next to each other. So we can say these two sides AB and AD are adjacent sides. And also these two adjacent sides are equal in length. Then AB and AD are congruent. The same stuff we can consider for the sides BC and CD. Because these two sides are next to each other, then they are adjacent sides and they are equal in length. Then BC and CD are adjacent. Okay, this quadrilateral ABCD has two pairs of adjacent congruent sides. AB and AD is one pair and the other pair is BC and CD. If a quadrilateral has two pairs of adjacent congruent sides, then it is kite. So clearly the quadrilateral what we have over here is kite. When this quadrilateral is a kite, then the diagonals AC and BD will intersect at right angle. Then we'll have right angle over here and right angle over here. Our aim is to get the length of the diagonal AC over here. For that, we can consider two right triangles. One is ABG over here and other one is BCG over here. In these two right triangles, we have to find the lengths of the two legs AG and GC. Once we get the lengths of AG and GC, we can add them to get the length of the diagonal AC. First, let me consider the right triangle ABG over here. In this right triangle, we know that AB is hypotenuse because it is opposite to the right angle. Okay, let's write a Pythagorean theorem in this right triangle ABG over here. That is sum of the squares of two legs, that is AG square positive GB square equals to the square of the hypotenuse, that is AB square. Okay, for AG, I don't have the length. Let's keep this one as it is. And for GB, we have the length 2. Let me plug in 2 for this GB, then we get 2 square. And for AB, we have the length 7, that is 7 square. Okay, then we get AG square positive. The value of 2 square is 4. The value of 7 square is 49. Let me subtract 4 from both sides of the equation. Then positive 4, negative 4 will cancel out. Then I'm getting AG square equals to 49, negative 4 is 45. Okay, now to get the exponent, we have to take square root on both sides of the equation. Okay, here on the left side, the square root and square will cancel out. We get AG. On the right side, we have square root of 45. Usually, when we take square root on both sides of an equation, one of the square roots will cancel out. And for the other square root, we will consider positive or negative sign. But on the left side, we have AG. AG represents the length of one of the legs of a triangle. It cannot be negative. So we don't have to consider positive or negative sign for this square root. We can consider only positive sign. And 45 is not a perfect square. So we can keep this for square root of 45 as it is. Okay, now let me consider the other right triangle, that is BCG over here. In this right triangle, we have to find the length of this leg GC. Now we can write a Pythagorean theorem in this right triangle, that is the sum of the squares of two legs BG square positive GC square equals to the square of the hypotenuse. BC is hypotenuse because it is opposite to the right angle. Okay, BC square And for BG, we have the length 2. Let me plug in 2 for BG. And for GC, I don't have the length. Let me keep this one as it is. And for BC, I have the length 20. Let me plug in 20 for BC. Then 2 square is 4, positive GC square. And the value of 20 square is 400. Let me subtract 4 from both sides of this equation. Positive 4, negative 4 will cancel out. GC square equals to 400 negative 4 is 396. Okay, now to get rid of this exponent, we have to take square root on both sides. When I take square root on both sides, square root and square root cancel out. GC equals to square root of 396. Okay, here I got the length of GC. Okay, here we can get the length of the diagonal AC, that is equal to get the length of the diagonal AC, we have to add the lengths of AG and GC, that is AG positive GC. Okay, here AC equals to AG equals to square root of 45 positive, GC equals to square root of 396. Okay, now I got the length of AC in this form, square root of P positive square root of W over here. Okay, at the place of P, we have 45. At the place of W, we have 396. So then P positive W equals to 45 positive 396. When I add 45 and 396, I am getting 441. Therefore, the value of P positive W is 441.